Hey everyone, this is Marcus. I am super excited to be bringing you Julien from Pinax, who's going to be going through his build with between Clickhouse and how he's using Substreams. So without further ado, I bring you Julien. Take it away.
Oh, thank you. Well, hi, my name is Julien and I work here at Pinax I've been working here for a few months. The goal of this presentation is to show us how we use ClickHouse to make substreams faster and more useful for our use cases. So I will go through these four steps. So at first, what is the motivation for using ClickHouse and how we use it? What is the architecture? So how we build it, how we constructed or build pipelines. Finally, we will go behind the scenes and just show the magic sauce of what is happening. And finally, we will go through how to use it, and we will just stream data in live. Hopefully, Discord will not make everything slow, but we will see in due time. If you have any questions or something is unclear during the presentation, just don't hesitate to stop me and ask questions. I'm here for that for, well, as long as you need. So, the motivation, there are two main points. So the first one is to split the data fetching part and the syncing process. So we want to isolate both steps. So one can go fast and one can go slow, or one can be as large as possible and one can be small as possible to make everything just completely isolated but work. The second part is to use the speed of ClickHouse to make queries in real time. So we don't want to pre-fetch data specified for specific use case. We want to have as much data as possible and then make queries that are fast, but take just what we need to use speed of ClickHouse to have the best queries as possible. So the architecture is fairly simple when we look at it from a high level. There are four main points. The first part you will all know is the substreams. So we just execute the substreams to fetch data from the blockchain. This is the tool built by StreamFast, written in Rust. We added these two stats in the middle, so the webhook sync and the Clickhouse sync, which I will go in more detail in the next. As I said before, everything goes up into Clickhouse, which is a database at the end. So it's for people that don't know Clickhouse. It's just a really fast database that is specifically engineered to make queries really, really fast. So something to the millions or the billions of records per second instead of a regular database, which is a bit slower. So the main advantage between these two syncs, so the webhook sync and the Clickhouse sync, is that they are loosely coupled. So as I was saying before, if we want to have one big webhook sync or many webhook syncs, we can. And if we want to have a Clickhouse sync that just crashes and then restarts, it won't be a problem. Everything is built to be resilient and work separately one from another. The second main point is that the Clickhouse sync is serverless, so there's no state and there's nothing to lose if something happens. We can just restart where we are or scale up or scale down as needed. As I was saying, if we want, we could have many substreams running into many webhook syncs that are all piped into ClickHouse. So this architecture allows us to, if we want, say, have the same substreams running on many chains at the same time, and all of the resulting data is just piped into the same database at the same time. So this will allow us to have the same data, but on different chains and get more interesting analytics and to have the correct information as fast as possible. This structure also allows us to have many different substreams running on the same chain, all of it at the same time at different speed or at different blocks at the same time. So there's really no limitation to use the Clickhouse sync in this configuration. Is that what's the word? Sorry, in English, is not my first language. Is that overview pretty clear, or are there questions on this way of working with substream? I will take that. That's it. Okay. So, if we go a bit more behind the scenes, at first we'll start with the webhook sync because it's the first part of the pipeline. What it does is First, it calls the substreams and it makes it run. So it will take in the data, add some metadata from coming from the sink. So information about who started it, on which chain, and what are the parameters. Everything is bundled up together and will be transmitted to the Clickhouse Sink until successful. So this means that if something happens, or if the Clickhouse Sink does not respond, or if something is slow, the webhook sync will scale accordingly, and it will wait or go a bit faster. It will make sure that the information will always go into Clickhouse, whatever happens. So with this very particular way of doing things, we are sure to not miss anything, but to go as fast as possible while keeping all of the information we need. If we go on the Clickhouse Sync side of things, this is the very large overview. So we take the information coming from the webhook sync, so the data plus the metadata bundled together, and we parse them to make sure that everything is correct. So the Clickhouse Sync currently is expecting entity changes. So it is the crate offered by Streaming Fast to explain the difference and then graphical schema. So we expect this input, and then everything we start into SQLite. So this makes sure that currently in our small local state, we keep everything that we receive just in a temporary little buffer. When something is written to this is when we return to the webhook saying, okay, it's fine. I received the records and I stored them successfully. If there was an error, we can just say, hey, something went wrong. Please resend the data, and we will make sure to. So this part of thing is the fastest. We can go up to currently a few hundred records per second. So if we have many chains in real time being synced, there's plenty of room to make sure that we can receive data from many subs. We are currently working on making the expected data a bit more broad. So that is why I wrote here the database change. So this is another created written by Streaming Fast. That is a possibility to receive data into the Clickhouse. So at this point, everything that came from the substream has been augmented by the webhook sync and stored into SQLite into the Clickhouse sync somewhere. What we want is to store it into Clickhouse. So what happens is at every few seconds, Clickhouse just takes the information into SQLite and applies everything as a batch into the specified tables. So this way of doing things is particular because we would expect everything to go directly into Clickhouse, but we do this so to make sure that the speeds are matching. So the main reason is that writing into Clickhouse is slow, but we want to go fast. So that's why we do it in all big batches. It doesn't matter how many data, how many records we write. We just want to be a few times per second. So this is the broader architecture of how everything is working. So if we want to go a bit more hands-on and try to load data into Clickhouse, there are a few steps that we want to use with this particular configuration. So the first step you will see in a few slides, it is just to create the default tables that are coming from the Clickhouse sync. So this is as simple as a click of the button. You will see it just now. Afterwards, for your particular substreams, you want to store the data in a particular table. So for this example, I have a clock substreams that just loads in the time at which a block happened. So we only store the seconds and the nanoseconds for this particular block. You will see that the schema is fairly simple. It's just plain old regular SQL, but written for ClickUp. What is interesting is that you can see here in the order by clause that some fields are not present in the columns that would be normally in the tables. This is done because when we create the default tables, we also inject into every schema that is provided to the Clickhouse sync a few more fields that will be always added. So that is the metadata added by the webhooks. So every time you will have the block number, the module hash, the timestamp at which the block happened, and the chain on which it happened. So this is why we can use these fields in the order by clause, because we, behind the scenes, add more columns to the table. So now that we have a table created on our database, we can go on, check out how really it works. So do you all see the video correctly? It's not playing right now, it's normal, but just want to make sure I'm not speaking. Okay. So what you see currently is on the left is the web UI that's running for the Clickhouse Sink. So you have a few HTTP requests that you can use to communicate with the process. On the right, you will have both the Clickhouse Sink on the top and the webhook sink on the bottom that I will be editing as far as the video goes to make modifications. So the first thing I do is I start up the sink to at first validate that we are starting with a fresh database. So we can here see that I'm just pinging the database to make sure everything is fine and everything was okay. The database is running and we can establish the communication. Afterwards, I run a simple query just to see what tables are on the database. So if we see here, there are no tables on the database. On the database, everything is clean and we start from fresh. Afterwards, before trying to set up everything in running data, I just want to make sure that there's a certain layer of security on our communication pipeline. So I will just create a simple, well, not so secure password for now, just to make sure that everything is under a certain layer of protection. So here I have I generated my hash and I will add it to the configuration. So now every request that is made through the web UI needs to be protected. This does not seem normal because I just edited the password, but normally users that use the web UI won't have access to the process running in the background. So this is just for the admin part of it. Great. So now I will authenticate with my super secure password. And here's the one-click button just to start up the database. So when we run the init command, you will see that many tables were created and the database is currently working for our use cases. So that's perfect. I will create schema. So this is exactly the code that I was showing you in the slide before, and I will run it against the database. So here my database, my table has been created, and we are ready, good to go to start and stream data. Just to make sure, I will rerun the tables query, and we see that the default tables are here, and the clock table that we created is also here. So everything is good to go. We'll go into the next slides to see how it's done. Sorry. Okay, so this is one way to do things. And this is the database structure that we currently have. So there are 4 main tables that are really useful for our use case. The first one is the schema that you created that is linked to the module hashes table. This table will contain metadata about what's happening on the database. There's also the blocks table that will just store information about every block that is, the final blocks table, which table has, well, final blocks. So the details, sorry, mute this channel. Okay, so the database looks like, so this is, as I said before, the default columns that are added, and here are the custom fields that you added when you create your own data. The module hashes, as I said, contain metadata about the substreams that's running, and also information to know where you want to start back. So there's the latest cursor, latest block, latest timestamp, just to make sure that everything is fine when we want to start back. We have that information. We have information about the blocks, as I was saying, and finally, the final block. So this is one way of doing things, but if we want, and if we don't want to write SQL, we can also use GraphQL entity schemas that we normally use to transform information. So here I have a schema that represents the clock as before. So it's the same thing with seconds and nanoseconds, but we can also run it against the Clickhouse Sink to generate a table. So what will happen behind the scenes is that these fields will be translated into their equivalent parts according to how these are defined. So in this case, Bigint becomes a string. So we do lose some precision, but we don't have any choice because this is how it's stored behind the scenes. And we also have an automatically generated order by clause. So for those who are not who don't know how Clickhouse works exactly, the order by clause is really important because it is what defines how a table is fast. So it will in memory store the information according to this clause. So if we make it sorting according to random data, well, Clickhouse will go at random speed. But if you store it by, let's say, timestamp, everything will be stored in order, and searching data will be pretty fast. So we can see that currently the order by clause is not necessarily the best, but we can make it good by specifying IDs to the schema in GraphQL. So this is the second way to create a table. And if we run it afterwards, so we go back to the screen where we started data. The sync is still running, and I'm starting the webhook sync on the side. So this will start the substreams, and as you can see, a lot of data is coming in. So if I start a query that just say, hey, how much block did I get in the last 5 seconds that the webhook was running, we see that we have now 2,000 blocks that came. So everything will continue and go as fast as it can, and we can see that we just got 5,000, 6,000 new blocks really fast. So this is as simple as that to run the Clickhouse Sink. We just start the process, and everything will connect together, and the data will be streamed. If we want, we can do a live demo afterwards. It will be pretty fun. So here we have data in SQL. In Clickhouse, everything is good. We can now make queries as we were just doing to get information. The final thing that is important to note is that now we spoke about SQL tables or GraphQL tables, but if we want to have we want to control everything that's happening in Clickhouse, there's also a way to do that. So we can break out of the regular pattern and use the unparsed JSON table. So the Clickhouse Sink allows us to use this particular way of doing things, which when you couple it with a materialized view. So again, for people that don't know how Clickhouse works, a materialized view is basically when data is inserted into Clickhouse, this particular object will just say, hey, I want the data, take it and apply modification and store it in memory. So this allows us to, when we insert data into this particular table, it will just take it, apply some modifications, and do whatever we want with it. This allows us to control what happens in Clickhouse. So this is an example of how we want to do it. We just write a specific table that is exactly how we need it, and we write a materialized view script that will take the information from unparsed JSON, apply some modifications, and then store it into this particular table. So currently this example, what it does is it takes every columns that is generated by the substreams and just store it in a table. It's a simple query, but it's not something that we could have done normally using the default Clickhouse Sink way of doing it. This is something that breaks out of the loop, but allows us to do everything that we want as fast as possible. If you want more information of that specific pipeline, you can just go to Clickhouse documentation directly. And so everything will work if you start the Clickhouse Sink using the allow unparsed flag. So yeah, that's pretty much how in broad view the Clickhouse Sink works. If you want, we can go ahead and do everything, just restart live. So I will restart the sink as I said before, and then start the webhook sync, and you will see that data is coming in, everything is going fast, and Discord is not making things slow. That's fantastic. And again, that's not the one I want. If I run a query here that just says, select how much data I have in the clock table. We are currently at 100,000 blocks that just came in our store in Clickhouse. And everything is painless. You can scale up as much as you want, and I could start as many webhooks as I want. Everything will be stored, currently locally, but you can host it however you want. So yeah, I think that makes a good overview. Do you have any questions on any slides or anything that wasn't clear?
I just want to say that's super impressive. Can I ask you a question about the Clickhouse integration with this? What is with Substreams, what is personally your favorite aspect of this, and in terms of what it allows you if you were to be building with this?
I think that my favorite aspect is, I think I have two favorites. The main part is really to have one central Clickhouse Sink that is the central process that stores everything. So I could run 1 or 10 substreams and everything goes as fast and as easily. But I think that my favorite part would really be the simplicity of doing things. So I don't have to bother about how I build my substreams or how I build my database. Everything will be fast in the end because the tools that we use are good, and we just have to specify a bit of optimizations, and we can get as much data as fast as possible and not much waiting time. So for just a regular computer, I get really a lot of data really fast. I think it's really fun.
That's awesome.
Help me answer correctly.
Yeah, no, that's great. Your answer is your favorite, so that is the correct answer.
Great, thanks.
Well, if anyone has any questions, feel free to hop in with the audio or on the chat. We'll be here for a little bit while longer if there is conversation to be had. But if not, I'm really impressed, Julien, by what you're building and what is going on with the integration between Substreams and Pinax, and really Clickhouse, and allowing this simplicity and speed all at once. It's really impressive.
Well, thank you. I must say, though, that even if I'm here presenting the Clickhouse Sink, I'm not the only one behind the scenes. There's many more people at Pinax helping me out and just giving me guidelines or just having good ideas. So it's a good group effort. Yeah.
It always is. It always is in crypto. Always is in Web3. You all got to do it together with this, especially when it's a bleeding edge like this. We all got to be coordinated as best as we can. So, awesome. Well, if that is it for this Graph Builders office hours, Julien, thank you so much for your time. If the viewers or anyone watching on the recording of this wants to get in touch with you or Pinax, what should they do? As well as this repo, where could they find this repo? Where can they build with this?
Yep. This repo is available on the Pinax organization, so I can link it if you want. Otherwise, there's blog posts or YouTube videos on the Pinax channel that explain all of this. So everything should be available directly on the Pinax GitHub repo. If you want to contact me, well, I guess I can link my email or directly via Discord. I'm always available.
Awesome. Yeah, if you could drop those links in the chat. We got Mike is asking about that. And for those of you in the audience, thank you so much for joining us on another Graph Builders office hours. Take care. Enjoy the rest of your day.
Great success.
Right. Great success. Great job, Julien. That was awesome.
Awesome. Thank you very much.
Yeah, just seeing it just come in live and then have the UI just be that simple. Very, very impressive. If you could just send over the links that you would prefer for your contact, if you want email or Discord, because we'll put this in the YouTube recording of this.
Yep.
And then also GitHub and all that, you could just DM me that information.
Yeah, sure. No
yeah. Awesome. Okay, everyone. Well, thank you for joining us and have a great rest of your day. Julien, take care. Thank you for your time, man. That was awesome.
Thank you very much. Thank you for having me.
All right. Bye.
Bye-bye.